Okay, we're going on to Chapter 8. In Chapter 8, what we're doing is giving you a number of other alternatives in solving quadratic equations. A couple of terms, principle of the square root, and completing the square. We'll be getting to those shortly. But as sort of an introduction, if we see something like this, x squared equals 9, in the past, it is a quadratic equation, and in the past, when we would solve this, we would say, well, put it in standard form. And we would go like this. Transpose the 9, and then equate it to 0. This is the standard form of the quadratic equation. Now to solve it, the only method we had up to this point was to factor it. Because this was the difference of perfect squares, and we're factoring it into its conjugates. So then we would say and we would get as our solution, x is -3, x is 3. Well, in this section, we're going to introduce this topic, the principle of square root. So if we had this equation, and what we'll be using in this section, and this sort of comes from Chapter 7, when we were dealing with, square roots and things. If we wanted to find out what x is, and this is a square unit, we could just take the square root of this side and the square root of that side. And this would be x, and this would be 3. Now notice, in doing it this way, how many answers do we get? Well, we only got one. If we did it this way, we got 2. And since this is an equation to the second degree, we need 2 solutions. We only got 1. So throughout this lesson and from now on, whenever we take the square root of something, in order to secure that we get 2 answers, we have to say plus or minus the square root of 9. So this way we get plus or minus 3. We ensure that we get both answers. Now this principle of square root is something we're going to be using, and that's why I wanted to have this little mini lesson to get us started off. In examples 5 and 6 in our booklet, we're asked to look at this equation. It's quadratic, and if we put it in function notation, it would be f of x is equal to this, and we're looking for y here, and y will be 0. And if we put it in our graphing calculators, you would end up with a parabola opening upward, and this point here would be a -7, 0, and this would be a 5, 0. But what they're asking us, just by looking at the graph, determine the number of real solutions from the graph. Well, the key to a real solution is that it has to cross the x-axis. That is, be part of the x domain, so to speak. And these are ordered pairs. These are x-intercepts, and they're crossing here and here. So the question is, how many do you have? Well, we have this one and we have this one. So the answer is we have 2 real solutions. Now as we look at number 6 and its graph, this is the information they give us, and this is the graph they give us. Does this parabola cross the x-axis at all? And the answer is no, it doesn't. So how many real solutions does this have? And the answer is 0. It doesn't have any real solutions. And we'll be getting to this a little bit later toward the end of the chapter, and then in other topics as we cover chapter 8. Okay, as we look at this board, we're going to be using the principle of square root. And again, part of it, as you look at an equation and you need to solve it, because these are all equations because of the equal signs, you have to figure, well, what strategy do I use? Well, again, we're using this primarily here. So we want to isolate the t-squared by dividing both sides by 6. We then get t-squared equals 3. And as I showed you earlier, when you have something like that, you're going to take the square root of this side and then plus or minus the square root of that side. So you get t equals plus or minus the square root of 3. And it's just that easy. All right, let's do this one. Again, we're going to transpose that because that's the sum of perfect squares. The sum of perfect squares doesn't factor in the traditional way that the difference of perfect squares do. So before we couldn't do that. We would say that's prime. But now this is going to become a negative 81. And we're going to get 4x squared equals that. We're going to isolate the x squared by dividing both sides by 4. And we now get x squared equals a negative 81 fourths. We're going to take the square root of this side, which gives us an x. Now this is interesting because this is a negative 81. Well, that's going to be a plus or minus. Now remember, the square root sign is there. We know our denominator is going to be 2, but our numerator, what did we say the square root of a negative 81 was? We did that in the last topic, and that was 9i. And a quick review of that, we had the square root of negative 81. That was the square root of negative 1 times the square root of 81. And this is I9. And that's where I get the I9 from, or 9i. And remember, there are two answers, a positive value of this and a negative. Now remember, this is an imaginary number. This is sort of like that parabola not reaching the number line. It doesn't reach the x-axis. That's why that's an imaginary number. Now what we're getting to here is going to be something very useful, because we have now a binomial that equals something. We're going to use the same technique. Take the square root of that and plus or minus the square root of that. Remember, by taking the square root of that, it just leaves the radicand, which is y minus 3 equals plus or minus 10. And then we transpose the negative 3, so we go y equals 3 plus or minus 10. And you don't leave the answer that way, you actually work it out. So 3 plus 10 is 13. 3 minus 10 is a negative 7. So those are your answers. All right, in this one, again, we're following the same pattern. We're going to take the square root of that, plus or minus the square root of that. That leaves the radicand, x minus 5 equals plus or minus the square root of 2. We just transpose the 5. X equals 5 plus or minus the square root of 2. And you might say, wow, that's not too hard. Again, there's a little recipe involved. So we have a binomial squared equals something. We take the square root of both sides. And this just becomes then the radicand. A plus 7 equals plus or minus. Now what is the square root of negative 4? Well, that's 2i. And then you transpose the 7. And notice that's in standard form of your complex number. Now, if they're all this easy, but they're going to give you some challenging ones as well. So for number 12, now we have a fraction and a fraction there. So let's see what we get here. We're going to take the square root of that, plus or minus the square root of that, and that gives us y plus 2/3 equals. Now this gets a little tricky, so what I'm going to do is work it out for you and save a little time. And it always works out better if you copy the numbers down right. I had these flipped, and that was what was giving me a problem. Okay, so I'm taking plus or minus the square root of 8 over 9. Now 9 is a perfect square, so I put that as 3. 8, you recall, is 4 times 2. Square root of 4 is 2, the square root of 2. So this is what I needed to have over there, and I wasn't getting it with these numbers flipped. So now I transpose this, and I end up with this. Now another way to write that would have been to put all of this over the 3, but this way is good too. You have to be careful. Sometimes you can do some canceling here, and you'd want to simplify that as you get your answers. Okay, sort of remember this technique because that's going to be very useful in what we're coming up to right now. Now as we move on, we're going to be giving you some theory as well as strategy. Here we're dealing with function notation. And they say the function of x is this, and then what would it be so that the function of x would equal 7? Well, let's write it out. X squared plus 12x plus 36 equals 7. Now, I don't know if you see what I see here. This is a perfect square trinomial that will factor into x, half of this, the quantity squared. Now we use the technique we've just done. Take the square root of both sides, and we get x plus 6 equals plus or minus the square root of 7. And we get then x equals negative 6 plus or minus the square root of 7. And that is correct. Now, notice in this case they already have a binomial that's squared, and they're saying that that equals 25. So let's write it again. T minus 8, the quantity squared, equals 25. So again, using the principle of square root, we take the square root of both sides, and it's key that you put plus or minus. Otherwise, you're not going to get two solutions. And this is then t minus 8 equals plus or minus 5. So when we bring this over, this is going to be t equals 8 plus or minus 5. And when we add the 8 plus 5, that gives us 13. And 8 minus 5, that gives us a 3. And then we are home. And that's the answer. We are building up to something. Now, I particularly like the drill they're giving you here to help you do the next part of this, which is called completing the square. Now here you see the first part of what we want to become a perfect square trinomial. And then you recall, if we had something like a plus b, the quantity squared, we would square that first. We would multiply these two together and then double it. And we would square the b term. And this is our perfect square trinomial. Well, what we're thinking of here is that this is the first part of it. So what we want this to equal is, what is your binomial square here? And we're missing a term. And if you recall, the standard form is ax squared plus bx plus c. So in a sense, we're missing the c term here in each of these. But how did we get the c term? Well, first, how did we get this middle term, which is this term right here? And let me just stress that if you master this, this is going to make this whole process very easy. Well, once again, to get our middle term, we multiplied these together and then doubled it. So this is 2 times something. This is 2 times something. So how do we get the opposite of 2 times? 2 multiplied. Think about it. And the answer is divide by 2. So if we divide by 2 here, what will that give us? That's going to give us a 10. Ah. And this is just going to be x. And now, what binomial would we have? Well, it's going to be this squared. But we didn't put our c term in yet. Our c term. What's our c term? Well, we have to square this now. That's going to be 100. So now if we factor that into its binomial squared, this is what we get. But I, over the years, developed a little technique for doing this. And I'm going to share it with you. So again, my technique was, you sort of set it up in standard form, put a set of parentheses, put your square there. We know this t is going to go here. The sign that's going to go there is negative. Now, how do we get this term here? Well, again, to get the middle term, we multiplied and doubled it. So here we have to take half of that. So what is half of 12? 6. And how do we get the C term then? We square the 6. That'll give us 36. And when we factor it, it becomes this. Now we need that C term, as you'll see shortly. But right now we're very much interested in this. Okay, well, they gave us a couple of easy ones. Now they're giving us something more challenging. But again, same technique. Make a parenthesis, put a squared there. We know this is going to be t, and this is going to be a plus. Now, we have to take half of this term, the 5. And the easiest way to do it is just go 5 divided by 2. Leave it as a fraction. So we're taking 1/2 of 5 is 5 over 2. That is, just multiply 5 times 1/2. And that's 5 over 2. Now, how do we get our C term? By squaring this. So this becomes 25/4. Okay? Now the equal sign is to put this over there. I just put it here. This is the technique. Number 18 is a little more challenging. But again, what have you developed so far? A parenthesis, squared, the x goes right there, this sign goes right there, and now what are you going to do? You're going to take half of this. Well, let's use that technique. 4 over 7 times 1/2. Notice you can cross cancel. So half of this would be 2/7. And there's the proof of it. And then what will our C term be? Well, we're going to square this. 4/49. Again, not too bad. And this is a little technique I developed over the years, and I would teach it to my students. And again, your teacher may have another method, and you may have your own too, but you want to be sure you get some results. And I guess I didn't write number 19 down. Let me write it down now. It's x squared plus x equals 20. Now, for this one, what they want us to do is to solve this equation by completing the square. So in fact, had they put this there, there's an equation in standard form, and we know it doesn't factor. Oh, maybe this one does. All right, but they want us to complete the square. So we will use this example to complete the square. Step 1 in completing the square, take the C term and move it to the other side. So that's what it was originally. They took the C term and they moved it to the other side. Now, so that leaves this spot open, and we want to do what is called completing the square. So we want to make this into a perfect square trinomial. And remember, our term here is a 1. So I'm going to put a set of parentheses, like we've been doing. They could have given us one a little easier, but this is okay. So x goes there, a plus goes there. What is half of 1? Well, 1/2. Now, what is 1/2 squared? Well, it's 1/4. Now, what we've done is we've added something to this side of the equation. It's no longer an equation, because what would I have to do to keep it as an equation? Because I've added this to this side. Well, the answer is I have to add 1/4 to this side as well. And I want to keep these together, and I'm going to have to deal with fractions later, so I'm going to convert my 20 to something with a denominator of 4. So can you see that this 20 is going to be 80 over 4? So I'm going to do that. In fact, I'm going to add the 1 to it, so I get 81 over 4 now. So again, there was a 20 there originally, and I'm adding 1/4 to it, and I now get 81 over 4. Okay. So now what I'm doing is I'm going to take the square root of this, now that I have a binomial squared, and this just becomes x plus 1/2 equals plus or minus the square root of that. Fortunately, they're both perfect squares, so this is going to be 9/2. And maybe you can see what's coming here. I'm going to transpose the 1/2 over, so I get now x equals negative 1/2 plus 9/2, comma, and 1/2 minus 9/2. I've written them twice, and that's a negative there as well. So now I have a negative 1, positive 9. That's going to give me 8 over 2, which gives me one answer as a 4. This is a negative 1 and a negative 9 gives me a negative 10 over 2, which gives me a negative 5. They could have given us an easier one. This is a little challenging. But our answers are a 4 and a negative 5. Now, I'm going to just do this up over here too. Because we had here x squared plus x minus 20 equals 0. And at first I said this couldn't factor, then I realized it could. And notice, when we solve it, x is 4, x is a negative 5. We did it by doing the process of completing the square. But again, you might say, wow, it's so much easier if we factor it. True, in this case. In some cases, it's going to be rather easy to complete the square, especially if you don't get fractions, as you'll see here shortly as we do some others. Okay, in these, no fractions. So I was kind of surprised they gave us that earlier one, but let's look at number 20. And we are charged with showing the work of completing the square to solve these. So this one, there is nothing in the C position. So now I'm going to put my parenthesis in squared. And we know the t goes there. The minus sign goes there. What's half of 6? 3. Square 3. And I should use the color here of what I'm adding to both sides. And that's going to be a 9. So I'm adding a 9 there. Now this is super important because this is where students may mess up. You've made this now a perfect square trinomial by adding 9 to this side. To keep it an equation, you have to add 9 to the other, and then you're going to factor this using this technique or whatever technique you use. So now we're going to take the square root of that. That just gives me t minus 3. And I'm going to add a 9 and a negative 8, and I get a 1. So this is going to be plus or minus the square root of 1, which is 1. So I now get t equals transposed by negative 3 plus or minus 1. So can you see 3 plus 1 is 4. 3 minus 1 is 2. Now an interesting thing happens. Anytime you see you get nice answers like this, you could have factored that. Because these are the factors of that. All right, now as we look at number 21, is that factorable in the traditional sense? And the answer is no, that wouldn't factor. So we want to use completing the square to do this. Step 1 is write this out. Take your C term and bring it over to the other side of the equation. So you have a little space for where the C term will go. Then you're going to put your parenthesis, bring the t down there, the negative sign there. What's half of 4? 2. And then square 2, that gives you a 4. And this is what I'm adding to both sides now. And again, that's super critical. A lot of students would get this far, but they wouldn't add the 4 to the other side. Then it's not an equation anymore. So we're going to take the square root of that, equals plus or minus, we're going to do the subtraction here, and we get the square root of 2. This now becomes t minus 2 equals plus or minus the square root of 2. We transpose the negative 2, t equals 2 plus or minus the square root of 2. And how did we solve that? By completing the square. We had an equation that wouldn't factor. And again, the key is you don't want to get fractions if you can help it. And 4, half of 4 is going to be 2. So it really works into completing the square. As you look at number 22, does that look like it's factorable? Nope. So let's do that one. So we're going to transpose the 2. Negative 2 becomes a 2 on this side. And I'm going to put my parenthesis, squared. X goes there. Plus goes there. Half of 6 is 3. So in this spot here, where I put the 2 there, I'm going to put a 9. So I'm adding a 9 to both sides. This 9 and this 9. This now becomes 11. I take the square root of this, plus or minus the square root of 11. This becomes x plus 3 equals that. X equals, transpose this to the other side, negative 3 plus or minus the square root of 11. Actually, this is not a bad way to do it. As long as your b term, this is your b term here, I think you're up here, the b term is a nice even number like that, boy, that works out really well. An easy way to work a quadratic equation. And again, we're using the principle of square root and the method of completing the square. Okay, here we're asked in function notation to find, and I'll read it right from the book, complete the square to find the x-intercepts of each function given in the equation listed. Okay, so what I did is I made up a little t-chart down here too, where I'll give the answers, because we're looking for the x-intercepts. Now remember, these are probably parabolas, and we're looking for the x-intercepts. And they've asked us to find it through completing the square. So let's do that. Remember, this is going to be equal to 0. So I'm going to go x squared plus 8x equals a negative 9. Take half of that. And when I square this, I'm going to get a 16. So this is going to give me a 7. So I take the square root of both sides. This gives me x plus 4 equals the square root plus or minus the square root of 7. So when I transpose the 4, here's what I get. I get a negative 4 plus the square root of 7. That would be one answer. And again, my negative 4, transposing that, minus the square root of 7. And those are my x-intercepts. You recall this was the official way to show the x-intercept. All right, same thing here by completing the square. X minus half of that is 2, the quantity squared, equals a negative 2. And I'm going to square this. So up here, I'm going to add a 4 to both sides. Up here I'm adding 4. Remember, this goes to this side, so I'm adding 4 there. So this then becomes x minus 2 equals plus or minus the square root of 2. So my intercepts then, once I transpose that, will be a negative 2 plus the square root of 2 and a negative 2 minus the square root of 2. Okay, I think that's good. Yep, those are good. All right, the rest of the examples, I did work them out, but they are kind of tedious. And basically, we'll do number 25 to show you what's going on. Now here, we see a quadratic equation where the a of the x squared is not a 1. So it doesn't lend itself to be solved by completing the square. So what I did, just to show you, is I took what was the original equation, I put it in standard form, And this is factorable, which is what I have here. And I got that x is 3/4 or x is 1/2. But then, according to the technique, and again, your teachers may be showing you this, in order to solve this by completing the square, you have to have the a term as a 1. So how do you do that? Well, the answer is you divide the x term by whatever a is, which was 8. But to keep it an equation, you have to do each term by 8. So that's what I did. I had to put it in standard form first and move the c term to the other side. So when I did that, here the 8's cancel out, and I get x squared. That's what I'm looking for. Here I could do some canceling. I could take a 2 out of there and get a 4. And that becomes a negative 5/4, which is what I have right there. And I divide this by 8 as well. And we'll get to that in a moment. Now, this is the part I'm interested in because I want to find what will be a perfect square trinomial for this. So I put the parenthesis with the squared. I take the square root of x, I get the x. Now I have to take half of 5/4. Well, I'm using that technique. 5/4 times 1/2 gives me my 5/8. So that's where I get that. And then now I have to square this to get my c term. So I square 5/8 and get 25/64. Now to keep this an equation, I have to add my 25/64 to the other side as well. And I have my original 3/8 there. Well, again, I have fractions with different denominators. So to make this 8 into 64ths, I multiply it by 1 in the form of 8/8, which makes this 24/64. Then I have 25 minus 24 gives me the 1/64. Okay. Now I take the square root of this side, it just gives me the radicand. I take plus or minus the square root of 1/64, that's going to give me 1/8. Plus or minus 1/8. I take my negative 5/8, move it to the other side, it changes its sign, and now I have this. All right, so I have 5 plus 1, that will be 6/8. 5 minus 1, that is 4/8. And what does these fractions reduce to? Well, 3/4 and 1/2. So it can be done. If a is not a 1, you could do it this way. But again, there's other easier ways to do it. In this case, factoring would have been a lot easier. And then in our next lesson, we're going to do what is called the quadratic formula, where that will be another choice. Now they have some problems that I'm not going to do because it'll make the tape too long. Again, I wanted to go over the principle of square roots and completing the square.